Now we are going to do exercise 6.1. It's on page number 96. Question number 1 is, what will be the unit digit of the squares of the following numbers? You have been given some numbers and you have to find out that if you calculate the square of these numbers, then what will be the unit digit? Means what will be the digit at one's place? The last digit, or you could also say in which digit the square of these numbers will end. Let us see how we have to write down the answer. There are 10 parts and I am doing 5 out of them. The other 5 you will do yourself. I will show you how to write the answer. So this is the number that you have. You want to tell that if we square this number, if we calculate the square of 81, what will be the last digit in the answer? This is what we want to find out. So what we're going to do is we will not calculate the square. Remember, we do not want to calculate the square because we have 5-digit numbers. We don't want to go multiplying this 5-digit number with itself. So what we will do is we will only look at the ones place. So the ones place is 1. This is the unit digit, the last digit. So square of 1 means 1 square, it is 1. So you will write down the square of 81 ends with 1. If you want, you can skip this step. Just looking at 1, square it in your mind, and then you can tell the answer will end with 1. Let's take this one. 1's place equals to 2. So 2 square is 4. So therefore square of 272 ends with 4. Looking at this, the ones place is 4. 4 square is 16. So what can you say here? Square of 1234 will end with 6. For this we have 7. So 7 square is 49 and 49 ends with 9. So square of 26387 will end with 9. You only have to look at the last digit. Take the last digit, write its square, see what that square ends with, and that will be your answer. So in the last part we have 25. Sorry, we have 5. So square of 5 is 25. So the square of this given number 55,555 will end with 5. If you want, you can also answer this directly because we have already made that table in the properties where we learned if a number ends with 1, 2, 3, 4, 5 up to 0, what will be the answer in the square? What will be the last digit? You can answer directly also. Now question number 2 of the exercise. They are saying the following numbers are obviously not perfect squares. Give reason. Now they are not asking you to check whether the numbers are perfect squares or not. They are telling you. They are telling you that the numbers are not perfect squares. You have to only give the reason. And for the reason you can go back to the properties that we have written. The last property where I explained about numbers ending with 2, 3, 7, 8 and odd number of zeros. That tells you that the numbers are not perfect squares when they end with the digits 2, 3, 7 or 8, or they have odd number of digits, and that's the reason we are going to give here. Out of these 8 parts, 5 of them have 2, 3, 7 and 8 at the end, so they are not perfect squares. First, second, third, fourth and sixth, they have 2 at the end, 3 at the end, 7, 8 at the end. Whereas 5th, 7th and 8th, they have odd number of zeros. 5th has 3 zeros, 7th part has 3 zeros, 8th part has a single zero, so the number of zeros is odd. That's why they are not perfect squares. Let's write down the answer. So what I have done here is I have actually separated the numbers. These are the numbers for which the reason is same. First, second, third, fourth and sixth part, these end with 2, this ends with 3, this ends with 7 and this ends with 8. So the numbers which have these digits at the end are not perfect squares, and this group of numbers has odd number of zeros at the end. Single zero, 3 zeros, 3 zeros. So this is a group of numbers which is not perfect squares. The reason will be the numbers which end with, or you can write down the numbers whose unit digit or the digit at one's place is 2 or 3 or 7 or 8 are not perfect squares. And for these, the numbers which have odd number of zeros at the end are not perfect squares. Now let us look at the next question. Question number 3. The squares of which of the following numbers would be odd numbers? This is kind of a multiple choice question. Out of the numbers given, which of these will have odd numbers as its square? So if you square 431, what will be the answer? Will it be odd or even? The square of 2826, will it be even or odd? The square of 7779, the square of 82004. And again, we are not going to solve the squares. We know it already. The square will be odd if the number itself is odd. The square will be even if the number is even. So out of these 4, whose square will be odd? The numbers which are themselves odd, and those numbers are 431 and 7779. Let's write the answer. Question number 3, the answer is, since square of an odd number is odd, therefore square of 431 part 1 and the third one 7779 will be odd numbers. Question number 4 and question number 5 are observe the pattern and find the missing digits. So what we have here is we have some patterns here. In question number 4, we have 11 square equals to 121, 101 square equals to 10,201, then we have the square of 1001, and then afterwards we have the square of 1,01,000 equal to, what they have done is they have not completely given the answer, neither have they put a blank completely. So they have written 1 here, there are some digits blank, then there is 2, and then some blanks, and then 1. So in between some digits are missing. And then finally for the last step, the complete answer is missing. You have to observe the pattern and then answer the missing values. Now if you look at the pattern here, you have 11 square as 121. You can calculate by multiplying 11 with 11, 121. Then square of 101, if you check by actual multiplication, 101 multiplied with 101, this will be the answer. Then for 1001, the answer will be this: multiply 1,01,000 with 1,01,000 to see what the answer will be here. Or what we can do is just observe what's happening on left hand side. We started with 11, then there was 1 0 between the two digits, then they inserted two zeros, then they inserted 4 zeros, then they have 6 zeros. The first and the last digit are same, 1 1. The number starts with 1, ends with 1. In between they are introducing more zeros. Based on that, similar thing is happening on right side. When there was no zero, in the square also there was no zero. When there was 1 0 between these two, the digits had 1 0 between them. When the numbers 1 and 1 have two zeros, right side also has two zeros in between. So if there are 4 zeros here, what will happen to 1 2 1 in between these two? So if zeros are inserted here, zeros are inserted here. If you insert 1 0 here, 1 0 here, 1 0 here will be introduced. If you put two zeros in between, here and here, we will have two zeros introduced. If you put 3 zeros between them, here and here also we will have 3 zeros. So same way, let's write the answer here. We have 1 2 3 4 zeros. So what will happen? 1 2 3 4, 1 2 3 4 zeros here. So keeping this in mind, let's answer this. We will have 1, we will have 2, we will have 1. 121 will be there, but in between there will be zeros, and the number of zeros will be from here: 1 2 3 4 5 6, 1 2 3 4 5 6, and 6 zeros here. Let us observe the pattern in question number 5. It is similar to the previous question. They start with the square of 11. 11 square is 121. Then they have inserted 1 0 here. Between 1 and 1 it becomes 101. Square is 10201. Just like here, the first two steps are exactly same. The change is happening at the third step. At the third step, they put two zeros together. But what they have done in this question, they have put 1 0 1 0 1. And the answer, if you calculate, the answer comes out to be 1020. I have noted down wrong, so this will be 1020302001. So depending on, I am just telling you what the pattern is or how it is working. If you have observed, you can fill up the blanks yourself. So what happened here at the third step, counting the number of ones, you have the counting going up to that number 1 2 3, then decreasing back. In between they had zeros, so we have zeros in between. This pattern comes from here. If you have the square of 11, it is 121. If you have the square of 111, it has 1 2 3 2 1 as the answer. If you have 4 ones, the square is 4 ones, so you go up to 4 and then come back to 1, 3 2 1. If you have 1 2 3 4 5 6 ones, squaring you get 1 2 3 4 5 6. Because there were 6 ones, we go up to 6 and then start in decreasing order: 5 4 3 2 1. So this is an additional pattern you can note down. Based on this, complete this now. So in this pattern, what they are doing, they are putting zeros in between. So they have put a 0 in between here. What happened? 0 introduced in between the digits. So 0 introduced after every digit alternately. 0 here, 0 here. So what will happen? After every digit we will have 0. This is what happened here. If you look at this step, compare this step with the third step on the top. So this one with this one. So 111. This is also having 3 ones, triple ones, but in between there are zeros. Now look at the answer. The answer here was 1 2 3 2 1, but the answer here has 1 2 3 2 1 with zeros after every digit. So if there were 1 2 3 4 ones, compare this. So the answer for here will be here. That means you're going to have 1 2 3 4, because there are 4 ones, and then we decrease 3 2 1, and we put 0 after every digit. So keeping that in mind, can you tell me how many ones will be here? Look at the counting. 1 2 3 4 5. Maximum is 5. So here we'll have 1 2 3 4 5 ones, and after every one you have to put 0, except for the last one. This is how pattern in question number 5 is working. Let us look at the pattern in question number 6. Question number 6 has a pattern something like this. Along with this, they have actually given you a clue also on the side. 1 square plus 2 square plus 2 square equals to 3 square. So we have 1 2 3 values added, and the answer is a single value, and all values are in square. Square value plus a square value, and the answer is also given as a square in all the rows. So observe the pattern from the first 3 and then try to complete the last 3. And the hint is the third number is related to first and second number. So there are 4 numbers in this row: first, second, third, and fourth. So this is your first number, this is your second number, this is the third number, and this is the fourth number, the last one. So this is first, this is second, and this is the third number. The first and the second number, they have a relation with the third one, and the fourth number has a relation with the third one. So this means the third number is obtained from these two, first and second. Using these two you get the third number. Using the third number you get the fourth number. And observe what's the relation here. So if we take this number, their product gives you 2. So 1 into 2 is 2. And over here, if you add 1, the answer comes out to be the next one. And over here, if you add 1, then you get this number. This is what's happening. Again, 2 multiplied with 3 gives you 6, and then 6 plus 1 will give you 7. This is how the pattern is working. So keeping this in mind, observe 3 into 4 is 12, then 12 plus 1 is 13. What will be the number here? 4, 5, here will be 20. 4 into 5 is 20. 20 plus 1 is 21. 5 into 6 is 30. Then 30 plus 1 is 31. In the last row, 6 into 7, it will be 42. 42 plus 1 will be 43. And all the numbers are squared. This is how you have the pattern for question number 6.